Okay, next question is question 8. Jolly old logarithms. I wonder how you got on with this one. See if you got the same answer as me. Okay, so this is the logs question with lots of logs lying around. I'm going to start by trying to reduce the number of logs I've got. So the left-hand side, log x plus log x minus 1. I'm going to use the log law to convert that into a new form, which is the log of x times the log of x minus 1. Now, it would be good if I could directly add the two logs on the right hand side together, but the thing that stops me from doing that is this 2 here. I first have to incorporate that 2 into the argument of the first log. So using another log law, that becomes the log of 2 squared plus the log of 3. So then we get the log of, if I multiply these brackets out, I get x squared minus x equals, 2 squared is 4 and 3 is 3. So when I combine these two logs together on the right hand side, I multiply the two arguments together like I did a moment ago on the left hand side, and I get log 12. Okay, so it's looking a little happier. If I've got the left-hand side, which is log of something, equals the right-hand side, the log of something else, then the two arguments must be the same. That means taking the, now I've got rid of all the logs, so I can just treat this just like a normal equation, normal quadratic, x squared minus x minus 12 equals 0, making it equal to 0 before I start solving it. And I can see that this one factorizes quite nicely. I don't have to use any other method like completing the square or the formula or whatever. So when I factorize this, x minus 4 times x plus 3 equals 0, from which I can write down x equals 4 and x equals minus 3. Now, this is the point in our log question where we have to be a little bit careful, because we can't have the log of a negative number. We cannot have the log of a negative number. Now, when we put the number 4 into here and here, we get two positive numbers. We get the log of 4 and the log of 3. That's absolutely fine. But when we put minus 3, negative 3 into the log x, we get the log of minus 3. And in the other one, we get log of minus 4. So those logs don't exist. So that means that x equals minus 3 is not a solution to the log equation. It's a solution to the quadratic equation, but it's not a solution to the log equation. So we can discount that, and x equals 4 is the single answer to this equation. How did you get on? I hope you got the same answer. If you did, well done. Did you use the same method? It's not the only method that can be used.